Hi guys, welcome back to Comfy Compositing. AI video has been stuck in 8-bit since day one, flat and washed out. The second you try to drop it into a real compositing pipeline, it falls apart. LTX just changed that. Their 2.3 model now has an HDR LoRA that outputs genuine 16-bit or 32-bit EXRs, the same format used in professional VFX pipeline, RE C3 and ACES CG, real grading latitude. I have built a full production workflow for this in ComfyUI, and I want to be upfront. This is not a one-click preset. This is an advanced, fully customizable pipeline. Every shot you put through, it is different, and the settings need to reflect that. There is a lot of controls in here, and that's the point. In the next 10 minutes, I'm going to walk you through every node, show you both EXR output options, and at the end, I'll drop it into Nuke so you can see what it actually looks like in a real pipeline when color graded heavily. Let's get into it. So here is the full workflow. Yes, it's big, and that's intentional. This workflow gives you granular control over every stage of the pipeline. Motion, timing, HDR intensity, upscale quality, output formats, and all of it is exposed and adjustable. Because every image you put through this is different. A portrait needs different settings than a landscape, a slow drift needs different steps than faster action, and there is no universal preset that works for everything. And this workflow doesn't pretend there is. What's happening at a high level, you feed in an image, LTX 2.3 generates the video from it, and instead of outputting a flat MP4, it converts it into HDR and saves EXR sequence. The key ingredient is the IC LoRA, trained by Latent on HDR footage. It generates RE log C3 color space and decodes to linear light, written to EXR. Real dynamic range, compositable, gradable, usable in a production pipeline. Let's look at the model requirements. First of all, LTX 2.3. I'm using 22B dev model, but you can use any of the distilled model or even GGUF if you're on low VRAM. I also use camera LoRA just to have more control over it. Next, I'm using a detailer LoRA for a little bit more details. And then next, distillation LoRA to speed up the process a bit. And finally, the upscaler to upscale it even further. Next, this is our regular video VAE file for encoding and decoding. This is our audio VAE, and this is our dual clip. Mind you, Gemma 4312P is a big model. So what you can do is you can also replace this with a GGUF model. And then this is our regular LTX 2.3 text projection model. I'll provide link for all of them over here. Simply click and download it. And don't forget to check out these extra information here. Moving forward, we simply load in one single image, since this is an image to video or HDR video workflow. Next, I have given over here some control for our settings. For example, width of the resolution, height, FPS, length, steps, CFG, K-sampler settings, and noise control. You can try playing with steps and reducing the distillation LoRA intensity. If you want higher quality, you can reduce this number and bump up the steps. And so the CFG. And you can also try playing around with different settings. Some of the important ones are Euler Ancestral, DMPP, UniPC, and LCM. Next, I generate a prompt based on what I would like for my final video. And then I use ChatGPT or Google Claude and write a detailed prompt. You can also use Gemma 4 to integrate it in your workflow and write the prompt directly in your workflow. This section builds the latent. Think of it as the canvas the AI is going to paint on. It takes your image, figures out the right dimension, and creates a blank video-shaped space for the sampler to work in. If you're doing image to video, your input image gets baked into this space as a starting point. Text to image, it stays blank. Audio gets added too and then everything gets merged into one latent that gets handed over to the sampler. That's it. Canvas is built. Now sampler takes over from here. And now let's talk about the sampling. This is where the actual generation happens. LTX scheduler takes the latent and your step count and builds the noise schedule, the sigmas. Think of it as a plan for how to remove the noise step by step. STG guider combines your model positive and negative prompts and latent into one guided signal. Sampler custom advanced runs the actual diffusion, noise in, video out, takes the schedule, the guider, and your sampler type and iterates through all your steps. LTX separate AV latent at the end splits the result back into video and audio latent separately. Now the shift values. Remember I mentioned it earlier? This is the important bit. Max shift value controls how much creative freedom the model has at the starting of the sampling. The high noise stage where broad motion and structures get decided. Base shift controls the transition, how the schedule curves from max down to terminal. Terminal is where the noise schedule ends. Lower is equal to cleaner output, but don't go below 0.05. So if your generated clip looks too stiff, push max shift up. If it's driving too far from your input image, pull it down. Every shot needs different value here. And then this is where the dual upscaling happens. First pass generates your video as base resolution. The upscale pass takes that result, re-anchors it to your video input images, and then runs a second sampling pass at a higher resolution using a separate lower noise sigma schedule, adding fine details without changing what was already generated. And this is where the SDR video is generated, but this is only for reference because we want HDR. This is the main section where the HDR processing happens. Let's look at it. So I'm using a distilled LoRa once again for HDR rendering, and I'm using the updated 1.1 distilled LoRa. And the next one is the heart of this workflow, HDR LoRa. Moving on, you don't need to change the positive or negative prompts. They are pretty good and they work for all kind of footages. Next, you might want to change the CFG if needed based on your work and the K-sampler settings, but everything else, the manual sigma or the strength index stays the same. And finally, these are the EXR output nodes. You can simply change your output folder path over here for the regular HDR, and this is for ACES CG EXRs. And then this is just for visual purposes. It does not save, but it will give you an idea of what it is saving. All right, now let's jump into Nuke and we will compare all the different output and results. So let's check this one out. So this one is SDR, and let's see how it compares with a regular HDR. This is in log space. And now over here, I have color corrected version. So you can see how much freedom we have to color correct. And now let's compare our dynamic range. So I'm gonna bring it down. And you can see this one is SDR, which is clamped at 1. You can see, and then this one is way higher. If I show you on my without color correction, we can see the values are going all the way to 7. And in SDR, they're clamped at 0.7. And then I have few more examples. You can see over here how much detail it's maintaining. You can see this is completely clamped. Let's look at the next one. You can see the skin. So much detail here. And everything is clamped in SDR, which is MPEG 4. The lights are also clamped. The sky is clamped. Let's look at this one. Same thing here. All of these lights clamped in the background. The details in the skin, the specular highlights are clamped. The reflections on the armor looks clamped. Let's look at this one. This one is quite interesting. You can see all of the detail on the fur is gone, but in this version we can see all the details. And if we compare our SDR, this is SDR, and then after color correction we can see all of these details. Same thing over here, no details, so much detail. You can see almost all of it, all of the hair detail. And mind you, I have simply added a little bit of lens sync to add some realism and color correction. I wanted to just test how much I can push the color correction, and I'm very happy with the output. And you can even see the eye details. Not much eye detail in SDR, and so much eye details when you're properly color corrected. And that is it. So this is the main workflow. Do try this out and let me know in the comments how did you like it. Thanks for watching and see you in the next one.